if the function is smooth, then function is differentiable. Now, can anyone tell me that what do I mean to say function is smooth? I mean, although I have not defined this smoothness mathematically, but still, like, anyone wants to say something about this smoothness? Gap means what? No breaks, no. Smooth means that slope of that function. Okay, smooth at some point. Okay, I'm talking about smooth at any point. Okay, smooth at some point. Let's suppose A. Then I mean the slope doesn't change drastically. Okay, so I mean to say here, smoothness means I mean to say that slope doesn't change drastically. Okay, which means, let's suppose if I say you that like I'm not doing any mathematical proofs or something, but I'm just giving you one intuitive idea. Let's suppose if I say that there is a function. Okay, there is a function that is this. Okay, maybe this function, and then let's suppose this is linear after this point. Okay, so suppose this is linear after this point. I mean, it becomes linear slowly, and then I say that here the function is something like this, and then maybe later it takes some other value, something like this. So now tell me, at this point, if I just ask you whether this function is smooth or not, then what you will say at this particular point? Is this smooth? Smooth means what? Slope should not change drastically. So what is the slope here? Whatever it is, right? Slope basically is in measured in terms of tan theta or something. So whatever slope it is basically it is something like this. I mean, the angle is something like this. And at this point, just before this point and just after this point, you look at the slopes. Just before this point, slope was something, which means maybe the tan theta is basically there. So I think it is negative, but I don't want to comment on this negative or positive or something like that. But anyway, like slope is something, and then this is again the tan theta, and the slope is something else. So basically, if you look at this point, then just before this point and just after this point. So basically, if I say this point is A, so I can say just before this point and just after this point, slopes are not same, right? So just before the point and just after the point. So if I talk about slope here, these two slopes are not same. So I will say that function is not smooth. This is just in the layman terms. Obviously, we will define it mathematically, but I will say if these two are not equal, then I will say the function is not smooth. Is this clear to everyone? Then it means function is not smooth, which means function is not differentiable at this point. So if the slopes are changing so drastic, okay, see, just within the interval of plus h and minus h, means that like just before that and just after that. So if slopes are changing so drastically, then I will say the function is not differentiable. Okay, you talk about any other point, maybe at this point, just before that, maybe if you say the slope is something like this, I mean the angle, just look at the angle. Okay, it is something like this. Just after that is also something like this, right? So so basically, like if I draw it, it might be something like this, and just after this might be, it doesn't matter, might be something like this also, right? So basically, if you just check at any other point here in this particular example, then it is not changing so drastic. So is this smooth here? Yeah, just before maybe something like this, just after maybe something like this, right? So yes, it is smooth here also. Now tell me, if I draw any tangent, okay, if I draw any tangent at for the any function, let's suppose, okay, so suppose whatever it is. So basically, if I draw any tangent here, let's suppose at this point, then like just I'm asking for your sake of knowledge, then just tell me, can it, if I'm drawing any tangent here, then can it cut the function also? Which means, I mean, okay, just a second. See, okay, I'm not able to draw a good function, but anyway, let me just try. If I draw a tangent at this function, then can this tangent cut the function itself later at some point in time? So answer is yes, right? So basically, let's suppose there is some equation of this tangent, whatever it is. There is some equation of this function fx. There is some equation of this tangent. Let's suppose lx. And if I say that how many roots are there for lx equal to fx, then what is your answer? How many times it is cutting? So for, I mean, how many points are satisfying lx equal to fx? 2 points, right? One is this one. Another one is this one. Another one is this one. Right? So 2 points are satisfying here. And actually, cutting and equal yeah, cutting and equal like two functions are meeting at some point. See, lx equal to fx means at which point both are equal, at which point of x, at which value of x both are equal, at this value, right? So at these two value both are equal. If you solve this lx equal to fx, then you will be getting these 2 points definitely. 100% you will be getting these 2 points. Okay. So anyway, like this is just one confusion that some people might be having. That's why I'm just telling you. Okay, let's not worry about this lx fx, these things. So what I'm only saying that this tangent can also cut the function. Okay, so it's not necessary that tangent cannot cut the function if you people have any of this kind of confusion. Okay, let's come back to the definition of differentiability. So when we say the function is differentiable, whenever the slopes are not changing drastically, so the function is smooth, which means the slopes are not changing drastically in the neighborhood. Slope does not change drastically in the neighborhood. Okay, so see, it is very important to write in the neighborhood, which means that you can't just say to me that okay, see here the function, the slope is something like this. I mean, at this point the slope is something like this, and it is not changing drastically. You can just look at this point. No, you have to look in the neighborhood only. Okay, just in the neighborhood. The things are defined just for the neighborhood. So that's very important. That's why we only have the local minima. There is no, like, as far as I know, I hope I'm correct. There is no algorithm that can actually find the global maxima or global minima directly. Okay. See, you can only find the local minima or local maxima. Always. There are okay, with my limited knowledge only, I'm saying that according to me, there is no algorithm. Like, I don't know if there is at all, but according to me, there is no algorithm that can find the global maxima or global minima. Okay, so I mean, you cannot find the global maximum, global minimum, because differentiability talks about in terms of neighborhood only, right? They only say that okay, this point is basically like we will talk about it later, but this point value at this point is lesser than the in the neighborhood. Like if you go little left, little right, then the value is minimum, right? So that's why it is a local minimum. But at later point in time, maybe some other minimum may come, right? Maybe some other minimum may come. So we always talk about the local minima or local maxima. We never talk about the global things, because we can't talk about the global things because there is no such no such definition we have defined for the differentiability in terms of global. So you have to talk about you have to talk about in the neighborhood. Okay. So now let's define the differentiability in mathematics. So what is the differentiability mathematically? Okay. So as we have seen that the equation of the slope, if we talk about equation of the slope, just to left of a, then what could be the equation of the slope? I mean, just with respect to the left of a, or in other terms, I can say that equation of the slope that is joining a point which is a comma fa and a minus h comma, uh, just a second. Okay, a comma fa, a minus h comma f of a minus h. So if I just talk about the equation of a like if I just talk about the slope of an equation which is joining these 2 points, then can you write that slope? Slope of the equation is equal to, so it will be, I think, by 2 minus by 1, which means I think f of a minus h minus fa. I mean, whatever, like, I mean, either you write fa minus f of a minus h, does not matter. Maybe whatever the convention you want to follow, you can follow. Okay. So this is a minus h upon minus a. So it will be f of a minus h minus fa upon minus h, right? This is the slope of the equation which is joining these 2 points. Now, that h in general could be anything, but am I interested in general h, or I'm interested in some specific h? Am I interested in taking h any value, or I'm interested in taking h just 10 to 0, right? So I'm actually more interested in taking the value h tends to 0, right? So basically, I will say that on the left neighbor, the slope is right. So I mean, with respect to the left neighbor, this is a slope. Now, can you talk about the slope with respect to right neighbor also? I think we can talk about, right? So maybe I can quickly talk about this. Shouldn't we take fa minus fa minus? Yeah, you can do anything. If you do fa minus h, it will be a minus h. I mean, you can just multiply -1 on the denominator and numerator. Does not matter. Okay, it will be then plus h. Okay, it does not matter. Like you can do in any way. You can multiply by the -1 here also and here also. Okay. Now let's just talk about the slope of the points which are on the right of this A, right? Okay, sorry. Am I taking too much of time just for the copy paste things? I hope Deepak could have written twice of this what I'm doing and taking in just copying and pasting. This is AFA, and then this is A plus H, FA plus H, right? Good. And by the way, like you can just give me a feedback. Am I using two less colors, or is this okay? Like the color coding that I'm using, is this okay? This is fine, right? Okay, okay. So slope of a point, slope on a point which is right to A. So what will the slope? It will be A plus H minus A. So it will be something like this, right? It will be this much. Slope will be this much. Now, what I'm trying to say, the way I'm trying to define this differentiability is like this: the slope on the left. I mean, if you come from the left, then whatever is the slope. If you go to the right, whatever is the slope, this slope should not change, right? So which means I will say a function is differentiable if slopes are same in. See, you always talk about neighborhood. okay, in neighborhood, which means slope with respect to the left will be f of a minus h, which should be same as right. Just left and just right की slope बिल्कुल same तो नहीं होंगे. So that's what I'm saying. This is where this limit comes. Limit h tends to 0. So if you zoom it maybe million times, then you will say you have to agree on this that slopes are same. Okay, it is not changing. Like I mean, you have to zoom it literally like billions of. You have to put the magnifier which is zooming it billion times, and then you will actually see that okay, the slopes are not changing. I mean, the points are actually same, almost same. No, it is not even the approx. It is basically since the limit h tends to 0, it means that you are talking about the exact thing. So this is called, yeah, this is called left hand derivative. Okay, this particular thing is called left hand derivative, and this particular thing is called right hand derivative. Now, is this definition clear to everyone? Do you would you believe that if I tell you some story regarding this particular definition? So so what happened? Like I was in the ISC classroom, and yeah, this is not obviously the fake one. And there is a professor. He's very popular professor. His name is Shirish Shavde. Shirish Shavde. If you go to ISC, then most probably he will be taking your interview like for any machine learning role. I mean, for any machine learning related course, which is MTech research or PhD or whichever it is. So I was in Shri Shavde sir's class, and then what happened? Like he was doing something related to function differentiability, and then he asked the basic, very core definition of function differentiability. That how does it got defined and like that. And then see, remember it is ISC class, which is itself a huge thing. Like it's not any Hululu college, obviously. It's ISC. And in that class, like very few students, I can say like 5-6 students just raise their hand to immediately, like he just asked that who has these things on top of their mind. Okay, which means that I mean, obviously it's IISc. So you pick a random student, and most probably the student like most probably the student is brilliant. Like, okay, you pick a random student. I have done that experiment. So like many times, like I used to wonder that okay, like I don't know, like initially when I went to the first semester, then initially I used to wonder that okay, maybe can I discuss with this guy, like this assignment, like will I be able to discuss this assignment with this guy, or I mean, would he be able to help? Like he doesn't seem to be intelligent. He's very quiet. He's very peaceful. Maybe he's struggling. And then I go to him, and then to my surprise, he knows almost everything. So basically, I mean, like you pick a random student, most probably he is brilliant. Like he or she is brilliant. That's what I see. So the professor asked that who has a basic definition in their mind, like how does differentiability is defined. So only in the class of 50-60, only 5 or 6 students raised their hand. And this was the moment that professor decided to ask this particular question in the interview also. And then later I got to know that whenever he have to ask something from the calculus, he always asks this kind of questions, like how you define this differentiability definition. So that's why it is better to know if you go to ISC for MTech research admission, then most probably if he has to ask something from the calculus, then there's a good chance that he will be asking these things. I mean, he has been asking from 2-3 years. That's what I got to know. So now tell me, what is this? Is this the equation of the tangent, or is this just a slope of the tangent? See, let's suppose, so like we also this is also called the f dash x at point A. Okay, at point A, basically f dash A, you can say f dash A, which is equal to this. So basically this is just a slope, which means like if you have, let's suppose, x power 4 minus x cube or something. Okay, this is a function. If you differentiate it, then it will be 4x cube minus 2x square or something, and you put the value okay, so you, if you just look at this, then first tell me that is this an equation of a line? Is this the equation of the line? Is the differentiation? Obviously no, right? This could be a curve. And first of all, these things, this is not even the variable. This is not even the variable. This is not even the equation, or not even the variable. This is actually, you are putting the value of A. like, I mean, which means you have to put the value a, and then you will be getting just one scalar number. How this scalar number could be the equation? So some people have this misconception that this is the equation. How this scalar number? This will be some scalar number. If you put a equal to 1, it will be 4 minus 2 or something like this, right? It will be a scalar number. How this scalar number could be an equation? So basically what I'm trying to say here is that this is not the equation. This is just a slope of the equation, okay? Slope of tangent at a, okay? And that's also called f dash a. So that's the definition of differentiability. Now let's solve this question. What they're saying, for c, which is a real number, prove that derivative of fx equal to cx is a constant function, right? Okay, can you prove it? I mean, using the basic definition of the differentiability. So what you need to do, you need to check whether this limit h tends to 0, f of a plus h minus fa upon h is the same as limit h tends to 0, f of a minus h minus fa divided by h, right? So if you do it, then what you're getting here divided by minus h. If you do it, then what you're getting here, and that is same as f dash a. Okay. So for any a, if you do it, then f of a plus h is basically c or c into a plus h minus c into a divided by h. It will be c, I think, right? Ca and ca will get cancelled out. It will be c. Similarly, here also it will be c. So here also it will be c. So since both the side you are getting c, that's why you can say that that f dash a is c for any a, right? For any a. I mean, this is constant, and that's how you can prove that this is f dash x is c. Okay. So that's very easy proof. You can prove it. I mean, this is a question from Berkeley University, but now this is a very basic question just to make you understand that even if you use the basic definition of the differentiability, then also you can differentiate. But we have direct formulas for the differentiation. We might not be using it, but it's very good to see that, okay, the basic definitions also work, right? You can differentiate just using the basic definition. Cool.